Electricity. Learning objectives. In this unit, we are going to learn to know the sources of electricity, to be aware of the equipments working on electricity and understand their applications, to know the different kind of electric cells, to be able to use the different types of cells, to understand the symbol of circuits and apply them in different circuits, to identify conductors and insulators, to be able to make their own batteries. Now let's move on to the lesson. Selvan and Selvi are twins. They visited their grandparents' village during the summer vacation. At 6 o'clock in the evening, Selvan's grandfather switched on the light. The whole house was illuminated, brightened with light. Seeing this, Selvan asked his grandfather, "How do we get light by switching on the switch?" So his grandfather took him to the nearest electricity board and inquired about the electricity. Now let us look into the conversation between Selvan and the engineer. Selvan: "Sir, how does the electric bulb lighten up when we on the switch?" Engineer: "Due to electricity." Selvan: "Oh, from where do we get this electricity?" Engineer: "We get electricity from thermal power, hydel power, tidal power, wind power, solar power, etc. or sources of electricity." Selvan: "Sir, do these plants exist everywhere?" Engineer: "No. These plants are constructed depending upon the natural resources available at that particular place. For example, we have thermal power plant in Neyveli because in Tamil Nadu lignite is available." Selvan: "Yes, I have seen windmills near the hills of Tirunelveli district which has potential wind resource. Thank you, sir, for your valuable information." Okay, Selvan. Selvan and his grandfather entered into the home and noticed the clock on the wall. Selvan: "Grandpa, look at the wall clock. How does it work?" Grandfather: "It needs electrical energy to work. Apart from other sources, we get electricity from cells and batteries." Selvan: "Yes, Grandpa. Now I am going to discuss about all this with Selvi. Any device from which electricity is produced is called the sources of electricity. We get electricity from different sources. For example, thermal power stations, hydel power stations, atomic power station, windmills, solar cells, etc. Let's know about each one of them in detail. Thermal power stations. In thermal power station, the thermal energy, which means heat energy, is generated by burning coal, diesel or gas, which is used to produce steam. The steam thus produced is used to rotate the turbines. That is, a rotatory engine activated by the reaction of a current of fluids. While the turbine rotates, the coil of wire kept between the electromagnet rotates. Due to electromagnetic induction, electricity is produced. Here, heat energy is converted into electrical energy. The major thermal power stations in Tamil Nadu are Neyveli in Kadalur district and Ennur in Tiruvallur district. Hydel power stations. In idle power stations, the turbine is made to rotate by the flow of water from dams to produce electricity. Here, kinetic energy is a form of energy. It is converted into electrical energy. Hydel stations have long economic lives and low operating cost. The major idle power stations in Tamil Nadu are Mettur in Salem district and Papanasam in Tirunelveli district. Atomic power stations. In atomic power stations, nuclear energy is used to boil water. The steam thus produced is used to rotate the turbine. As a result, electricity is produced. Atomic power stations are also called as nuclear power stations. Here, nuclear energy is converted into mechanical energy and then to electrical energy. The major atomic power stations in Tamil Nadu are Kalpakkam in Kanchipuram district and Kudankulam in Tirunelveli district. Next, windmills. In windmills, wind energy is used to rotate the turbine to produce electricity. Here, kinetic energy is converted into electrical energy. The major windmills located in Tamil Nadu are Aralvaimozhi in Kanyakumari district and Kayatharu in Tirunelveli district. Now, apart from these power stations, solar panels, which are prevalent in many places, are used to produce electricity. Solar panels are an arrangement of solar cells mounted in a frame and covered with glass. It is also known as solar PV modules or solar plates. Next, we are going to know about a cell and a battery. Cell. It is a device that converts chemical energy into electrical energy. When two different metal plates are inserted into an electrolyte, a chemical solution which produces positive and negative ions. As in electrodes, that is anode and cathode, to form a cell. Due to chemical reactions, one electrode gets positive charge, that is anode, and the other gets negative charge, that is cathode, producing a continuous flow of electric current. Now, depending on the continuity of flow of electric current, cells are classified into two types. They are primary cells and secondary cells. Let's know more about each one of them. Primary cells. Primary cells cannot be recharged often. They can be used only once. The primary cells are usually produced in small sizes. Examples of primary cells are clocks, watches, toys, etc. In this picture, you can identify the different energy cell sizes. Next, let us know about secondary cell. A cell that can be recharged many number of times is called secondary cell. These cells can be recharged by passing electric current. So they can be used again and again. The size of the secondary cell can be small or even large depending upon the usage. While the secondary cells used in mobiles are in the size of an ant. The cells used in automobiles like car and buses are large and heavy. Examples of secondary cells are mobile phones, laptop, emergency lamps and vehicle batteries. Children, in this picture, identify those objects which uses primary cell and secondary cell. First, watches. It uses primary cell. Car. It uses secondary cell. Mobile phone. It uses secondary cell. TV remote. It uses primary cell. Emergency lamps. It uses secondary cell. Good. Battery. Often we call cells as battery. However, only when two or more cells are combined together to make a battery. A cell is a single unit that converts chemical energy into electrical energy, and a battery is a collection of cells. Sylvie's grandfather asked her to bring the torchlight. While taking the torchlight, it fell down and the cells came out. She was afraid that grandfather might scold her. She started crying. Her uncle came there and asked her to stop crying and said that I will help you to fix the torchlight. Now the torch glows, Selvi's face also glows. Uncle told her the reason and explained to her about the electric circuits in the torch. In this picture, can you see the inside view of a torch? It has a bulb, battery, switch and a circuit. An electric circuit is a continuous or unbroken closed path along with electric current flows from positive terminal to the negative terminal of the battery. A circuit generally has four components. Let's see. A cell or a battery, which is the source of an electric current. Connecting wires, which is used for carrying electric current. A bulb. It is a device that consumes the electricity. A key or a switch, which can be connected anywhere along the circuit to stop or allow the flow of current. Let us know about the open circuit and closed circuit. Open circuit. In this circuit, if the key is open off condition, then electricity will not flow and the circuit is called an open circuit. The bulb will not glow in this circuit. Closed circuit. In this circuit, if the key is closed on condition, then electricity will flow and the circuit is called a closed circuit. The bulb will glow in this circuit. Now, let's learn about the different types of circuit. Simple circuit. It consists of a cell, key, bulb and connecting wires is called a simple circuit. When the key is closed, the bulb glows, and if it is open, the bulb does not close. Series circuit. If two or more bulbs are connected in series, that is in a straight line, then this type of circuit is called series circuit. If any one of the bulb is damaged or disconnected, the entire circuit will not work. Parallel circuit. If two or more bulbs are connected in parallel, that is one below the other, then this type of circuit is called parallel circuit. If any one of the bulb is damaged or disconnected, the other part of the circuit will work. So, parallel circuits are used in homes. We use the figures for identifying different electric components. Using electric components in complicated circuits is difficult. So, symbols of the components are used instead of figures. If these symbols are used in electric circuits, even complicated circuit can be easily understood. Let's see the symbols of electric components. Electric cell. The symbol for electric cell is this. It has a longer terminal that refers to the positive charge and a shorter terminal that refers to the negative charge. Battery. The symbol for battery is this. It has two or more cells connected in series. Switch open. The symbol for switch open is this one. It represents that the switch is in off position. Switch closed. The symbol for switch closed is this. It represents that the switch is in on position. Electric bulb. It has two symbols. First one, the bulb does not close. Second, the bulb closes. Connecting wires. It has a symbol of a straight line which is used to connect the devices. Now let us make a short recap of what we have learned. What is electricity? The flow of electric charge in a circuit is called electric current. We have also learned the different types of circuit. Simple circuit, series circuit, parallel circuit. Simple circuit. It consists of a cell, key, bulb and connecting wires in a simple arrangement. Series circuit. It consists of key, bulb, battery and connecting wires in a series arrangement. Parallel circuit. A circuit consisting of a battery, key, bulb and connecting wires which is arranged in a parallel position. We have also learned about the different types of cells, primary cell and secondary cell. Primary cell are can be used only once. Secondary cells can be recharged by passing the current and it can be used again and again. Connecting wires. It is made up of conductors and it is covered with insulators. Children, do you know electric eel is a kind of fish which is able to produce electric current? This kind of fish can produce an electric shock to safeguard itself from enemies and also to catch its food. Ammeter. Ammeter is an instrument used in electric circuits to find the quantity of current flowing through the circuit. This instrument is to be connected in series. Will electric current pass through all the materials? If an electric wire is cut, we could see a metal wire surrounded by another material. Do you know why it is so? Because it preserves the wire material against environmental threats and resists the electrical leakage. Let's learn about what are conductors and insulators. Conductors. The materials which allow electric charges to pass through them are called conductors. Examples of conductors are copper, iron, aluminium, impure water, earth, etc. Insulators. The materials which do not allow electric charges to pass through them are called insulators or else non-conductors. Examples of insulators are plastic, wood, glass, rubber, china clay, ebonite, wool, fabric, paper, etc. What happens when you get shocked by electricity? Yes, it leads to an electric shock, which occurs when a person comes into contact with an electrical energy source. Exposure to electrical energy may result in no injury at all or may result in devastating damage or death. Let's see the safety measures to safeguard a person from electric shock. First, switch off the power supply. Second, remove the connection from the switch. Third, push him away using non-conducting materials. Give him the first aid and take him to the nearest health center. Children, let's know about Thomas Alva Edison. He was born in February 11, 1847 and died in the year October 18, 1931. He was an American inventor. He invented more than 1,000 useful inventions and most of them are electrical appliances which is used in homes. He is remembered for the invention of electric bulb. In 1877, he had invented phonograph. In 1879, he had invented incandescent light. In 1891, he had invented motion picture camera. Thomas Alva Edison was one of the first to apply principles of mass production. Let us do an experiment to produce electricity using copper plate, zinc plate, connecting wires, key, beaker and porridge, that is rice water. Fill the two beakers with porridge. Connect the copper plate with the positive end of LED bulb and zinc plate to the negative end of the LED bulb. Now observe what happens. The LED bulb will glow with low energy and less amount of electricity is produced. Now you can replace porridge with curd, potato, lemon, etc. and do the experiment and observe what happens whether the LED bulb glows brighter or in dull.
Now let's see a short biography of an English scientist, Michael Faraday, who contributed to the study of electromagnetism and electrochemistry. He was born on 22 September 1791 and died in the year 25 August 1867. Michael Faraday came from a very poor family His father was a blacksmith who suffered poor health. Before marriage, his mother had been a servant. The family lived in a degree of poverty. Michael Faraday attended a local school until he was 13, where he received a basic education. When he was 14, he was apprenticed to a local bookbinder and during the next 7 years educated himself by reading books on a wide range of scientific subjects. Michael Faraday was eager to learn more about the world. He did not restrict himself to binding the shop books. After working hard each day, he spent his free time reading the books he had bound. Two books in particular captivated him: the Encyclopedia Britannica and Conversations on Chemistry, written by Johnny Market. Faraday's education took another step upward when William Daines, a customer of the bookshop, asked if he would like tickets to hear Sir Humphrey Davy lecturing at the Royal Institutions. Sir Humphrey Davy was one of the most famous scientists in the world. Faraday jumped at the chance and attended 4 lectures about one of the newest problems in chemistry, defining acidity. He took notes and then made so many additions to the notes, which he bound and sent to Davy as a tribute. Sir Humphrey Davy had been impressed by the book Faraday had sent him. Faraday sent a note to Davy asking if he might be employed as his assistant. Davy sent a message to Faraday asking him if he would like the job of a chemical assistant. Faraday began to work at the Royal Institution of Great Britain at the age of 21 on March 1, 1813. His salary was good and he was given in a room in the Royal Institution attic to live in. He was very happy with the way things had turned out. Faraday had begun more sophisticated experiments in his leisure time. He invented dynamo and designed the forerunner of the electric motor based on Hans Christian Ørsted discovery that a wire carrying electric current has magnetic properties. Although in Faraday's lifetime people had started to use the word physicist, Faraday disliked the word and always described himself as a philosopher. He was a man devoted to discovery through experimentation, and he was famous for never giving up on ideas, which came from his scientific intuition.
Children, keep in mind all the experiments with electricity should only be performed with batteries, which is used in torch or radio. Do not perform the experiments with the electric supply in your home, farm or school. Playing with household electric supply will be extremely dangerous. The best way to start saving on your electricity cost is to get smart with how you use the electricity. So use less energy, help the environment and save your money. Hope you have learned and understood the lesson on electricity.